the difference between a vector and a scalar. Who can tell me? Yep.
Vector has magnitude and direction.
Good. A vector has both magnitude and direction versus a scalar that has just magnitude. Who can give me an example of a vector quantity? Some quantity, some measurement, some symbol that has both magnitude and direction. Yep. Okay, so if I'm driving in a specific direction, that would be my velocity. Okay, we'll talk more about velocity in a little bit. Sure, velocity would be one. I'm not going to write that down quite yet because that's going to go with the lesson for today, but absolutely it would be a vector because direction matters. Is your hand up? Position, yeah. Position is a vector. Position is essentially the location of an object, and the location of an object, of course, has a direction associated with it. If you want to find something, you need to know where it is, and where it is includes a direction relative to something else. We got position as a vector. Anything else that's a vector? Yep. Velocity is a vector, but we're going to wait on that one until a little bit later today. Displacement is a vector, which is defined as the change in position, right? The change in location. I'm going to spell that right this time. Displacement. That leaves us with, of the stuff that we've learned so far, only one scalar. And what would that scalar be? Yep. Distance. Good. Now, we can find the distance and or displacement in two ways. The distance would be delta d. The displacement would be delta d with the arrow over, right? We find them both essentially the same way. Let's just write down displacement. Okay, displacement can be found in two ways. What are they? If we're given displacements already, in other words, if I walk 10 meters to the east, and then I walk 5 meters to the east, then how am I going to find the total displacement? Yep. Add them up. If I'm given displacements, if I'm given how far I've gone, then you're going to add them up. So we're going to say, in this case, it would be delta d1 plus delta d2. Let's say we add displacements. On the other hand, if I'm given positions like this, I am 2 meters north of the whiteboard. Now I'm 7 meters north of the whiteboard. Those are positions. Those are my locations. What do I do with those? I subtract them, right? So we're going to say the final position minus the initial position, or we're going to subtract positions. Now, it is possible to have more than 2 displacements or positions. If you have 15 different displacements, let's say I walk 2 meters, and then I walk 3 meters, and then I walk 2 meters again, and then I walk 17 meters, and then I walk 24 meters, and then I walk 1 meter. All I got to do is add all those displacements up, no matter how many there are, to get the total displacement. If I'm given 20 different positions, what do I got to do? Final minus initial. My initial position is 2 meters north of the whiteboard. Well, now I'm 4 meters north of the whiteboard. Now I'm 7 meters north of the whiteboard. Now I'm 3 meters north of the whiteboard. What's my displacement? Final position minus initial position, or 3 minus 2 gives me a total displacement of 1 to the north. Make sense? Final minus initial. So if you're given 20 different displacements, add all 20 up. If you're given 20 different positions, then just take final position minus the initial position. You're going to see that rearing its head in, I forget whether it's number 8 or number 9, or maybe it's both of them, on the worksheet that I gave you last week. First worksheet that you've done this year, question number 8 and number 9, but specifically right now number 8 says, a man begins driving his car 50 kilometers east of Banff. Let's Let's not go any further right now. What do we have given to us here? He begins driving his car 50 kilometers east of Banff. What is that? Yeah, that's a position. That's a location. That's where the man in his car is. It's not necessarily where he's staying. Like, he may change that position, but at that moment, that's his location. We're going to call that my initial position. By the way, I'm going to define east as positive, so that would make my initial position 50, positive 50. I really should write in positive there. Doesn't really matter, though. The reason I like to write in positive there is to remind me that it is a vector, and the direction does matter, and the sign does matter. If it's a scalar, it's going to be positive as well, right? But I'm just reminding myself here that direction is important. Okay, a while later, the man in his car is 300 kilometers east of Banff. Then even later is 400 kilometers east of Banff. Listen, my final position here is going to be 400 kilometers, right? But then I've got another displacement or another position in between. We'll call it, what do you want to call that? Let's just, you know what? Let's call it DM, the middle position. Does that make sense what I've done there? So my initial position is 50, my middle position is 300, and my final position is 400. All three of those, by the way, are to the east, so all three of those are positive. What's the distance the man travels? You know what, let's do B first. What's the displacement of the man in his car? Displacement is final minus initial position. That's 400 plus 400 minus 50 gives me 350 kilometers. That's my displacement, 350 kilometers. What did the 300 come into play here? It didn't. Like, in the middle of this thing, this guy was 300 kilometers east of Banff. But guess what? He was also 294 kilometers east of Banff, and 321 kilometers east of Banff, and 399 kilometers east of Banff. Who cares that at one point he was 300 kilometers east of Banff? Who cares? All we care about is that he started 50 kilometers east, and he ended 400 east. Final minus initial is 350. Does that make sense? What's the answer to A? What's his distance traveled? This is displacement, right? You'll see in a second why I did displacement first. Quick, what's the quick answer to that? What's the distance traveled? 350. How come it's the same number? Because I didn't change direction. I'm not going to put the positive in there. It is positive, right? But for distance, it's always going to be positive. I don't write the positive in there because I kind of put that in there just to remind me that the direction matters for that. If you left off that little positive sign there, I would mark that right still. Okay? I just like to put it in there to remind me. Make sense? Question 9 is a little bit harder because we changed direction here in number 9, so the distance and displacement won't be the same value. Number 9, we're going to say my initial position. Once again, by the way, in number 9, we're going to make east positive. So everything to the east will be a positive number, everything to the west will be a negative number. My initial position is positive 50 kilometers east of Banff. My final position will be 150 kilometers east of Banff. I'm going to call it my middle position, or I could call it D1 or D2 or D3, or maybe Instead of calling them DI and DF and DF, maybe I call them D1, D2, D3. It doesn't really matter what you call them, as long as you remember which is initial, which is final. My middle position is 300 kilometers east of Banff. Are those displacements or positions? Those are positions. Those are locations. Those numbers represent where the man and his car are at different times. So we're going to find the displacement. Once again, we'll do B first. Say df minus di, the final minus the initial. The final is 150. The initial is 50. My displacement is 100 kilometers. How many people got that? Okay, good. Distance is a harder one here. The distance is not 100. It's not the same as displacement. How come it's not the same number this time? I was 50 kilometers east of Banff, and then I was 300 kilometers east of Banff. So I traveled to the east. And then I was 150 east of Banff. So which way did I travel this time? West. All right, I went east a long ways, and then I went back west part way. So I switched direction. So therefore, distance and displacement won't be the same number. Here's what you got to do, and this is a tough one. For this one, we've got to say the distance traveled the first time when I went from 50 to 300 was 250 kilometers. And the distance traveled the second one when I went from 300 to 150 is 150 kilometers. Does that make sense? Like here's, let me draw a picture of this here. Here's Banff. This is going to be east. This is going to be west. Okay, my initial position is 50 kilometers east of Banff. And then I went to 300 kilometers east of Banff. And then I went to 150 east of Banff. So when I went from 50 to 300, I traveled 250 kilometers. And then I went from 300 to 150, I traveled another 150 kilometers. So my total distance traveled would be D1 plus D2, which is 250 plus 150. Two different numbers for distance and displacement because I changed direction. I went east and then I went west.